Yeah, so question 23 was also a challenging question, right? So in this question, we have like a triangle or a circle is placed in each of the 9 squares in a 3x3 grid. So shown below is a sample configuration with 3 triangles in a line. So we want to know how many configurations will have 3 triangles in a line and 3 circles in a line. So this is a pretty standard counting problem. So basically the idea here is we want to focus on the restrictions, right? So we want 3 triangles and 3 circles. So we have like a 3x3 grid. And then we want to put like triangles and circles on them. So the idea for this question is like we want 3 triangles in a row and 3 circles in a row. So the idea is like, let's say you have like 3 triangles here, right? Triangle, triangle, triangle. So if you have a column of 3 triangles, then notice that you cannot have like a row of 3 circles, because like you can't have like a row of 3 circles because like the triangles are all like taking up all the slots. So like if you have like a column of triangles, then you have to have a column of circles. Like you can't have like a row of circles. Like you can't have like circle, 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 because then the circle and the triangle would coincide on the same square, which is illegal. So if the triangles like form like 3 triangles in a column, then the circles also have to be in a column. And similarly, like if you have like 3 triangles in a row, then you have to have 3 circles in a row. Like you can't have 3 circles in a column because the triangles are all taking up the spots. So this is kind of like the main idea, right? So let's first take a look at this first case. These 2 cases are very symmetrical. So like technically you only need to do like work for one of the cases and then like double it kind of. So let's take a look at this case, right? Like if you have like a column of 3 triangles and a column of 3 circles. So notice that like you have 3 columns in total, right? You have 3 columns in total. So there are 3 ways to choose which column you choose. Like there are 3 ways to choose which is the column with all triangles. And then after you choose that, you have 2 columns left to choose which column has columns of all circles. So 3 times 2. Then you have like 1 remaining column left, right? So after you chose the column of 3 triangles and the column of 3 circles, you have like 1 column left that's like empty. So you need to fill that empty column with circles and triangles. So this question's like kind of tricky because you might think like the general idea might be like most people might think, you know, each of these 3 squares, right? You have 3 squares here. Each of these 3 squares, like you can put a triangle or a circle. So you might think that you just do times 2 to the power of 3, right? Like because each yellow square can be a triangle or a circle. So since you have 3 yellow triangles, then in total you have 2 to the power of 3 possible ways to put the triangles and circles. The reason this like, okay, so if you were to proceed with this like logic, right, and then you would calculate this, you get like 48. And if you do the same thing here, you'd also get 48. So if you do 48 plus 48, you get E, which is 96. And then like after the test, when you check the answer key, you get depressed because like that's not the right answer. And the reason is because like, especially in counting problems, you have to be very careful with like over counting. So we actually kind of like over counted here because like notice that like, okay, let's take a look at like this example, right? So let's say you had like the 3 triangles and you have the 3 circles. Like if we were to choose like this column to have all blue circles, right? Or not necessarily blue, all like circles, right? Like that would like overcount the case if we like first, okay, let's draw another 3x3. So wait, let me first erase this. So let's say you had like another 3x3 grid with like 3 triangles like that. And let's say the 3 like circles were in like this column this time. So if you were to do this like 2 to the power of 3 trick that we just talked about here, then like in the 2 to the power of 3 possibilities, that would count the case of having 3 blue circles in a column. But like that would also count it here, right? 3 blue circles in a column. So like this kind of like overcounts. Like this configuration, for example, is counted 2 times. Like you don't want to count it multiple times. You want to count it exactly 1 time. Which is why like 2 to the power of 3 kind of overcounts it. So hopefully that made sense. So basically to like prevent this overcounting, what we have to do is we kind of have to like take 2 cubed, but we have to like minus 2. This minus 2 represents the case when like the entire column is either all triangles or all circles. Because as we saw here, like this configuration is kind of overcounted. So this -2 takes out the overcounts. So basically, this would give us 3 times 2 times 6. And that would give us 36. And this case would also give us 36. But like, the reason this is also not correct, like if you do 36 plus 36, you might think it's 72. Oh wait, that's not even an answer choice. So like, if you got 72, you could be like lucky and be like, oh, at least that's not an answer choices. And the reason we're still not done yet is because like we just like in the previous, when you just did 2 cubed, when you did not do the -2, we counted this like configuration 2 times. But when we did the -2, we subtracted out these cases. Like then in that case, then like these things, instead of being counted 2 times, they're counted 0 times. So now we're undercounting, kind of like we're counting less than what we're supposed to be. So we have to like re-include these cases back into our count. So we have to like add back the cases where you have like a column of triangles and 2 columns of circles, and similarly 2 columns of triangles and 1 column of circles. So like to add back the overcount, the undercount, you have like 3 possible ways to choose what column the 3 triangles go in. So let's say like the 3 triangles go in this column. And then the remaining circles have to go into like the remaining 2 places. So like here, 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 here. So like you only have like 1 choice. So that gives us 3 choices. But like you could have like instead of having 2 columns of circles, you could have had 2 columns of triangles, right? Like you could have, instead of circles, you had triangles in these places. And instead of triangles, you could have circles in these places. So like you have to do like this number 3 times 2 to get 6. So you actually have to add back 6 into the actual total count. So 36 and 6 gives us 42. So 42 is the actual number of ways to color this first possibility. And by symmetry, just like by a symmetry argument, since these are all symmetric, the second case like this, having a row of triangles and a row of circles also has 42 possibilities. So if you were to add 42 and 42, the 2 cases, you would get like 84, which is D as the answer.